Unit 4 of Algebra 2 deals with rational functions. And so these are functions where the variable is in the denominator of a fraction. And so things get a little bit messy here. We have to use a lot of our fraction rules. We have to use a lot of our properties of dividing with simplifying fractions, etc. We're going to do some factoring. It's going to be some awesome stuff. We're going to focus today on what is called the reciprocal function, which is y equals 1 over x. We're going to do some transformations and translations and stretches with this function to sort of begin to understand a little bit of the nature of these things. In order to do so, we want to think back about domain and range and how a domain and range may be affected by translations or stretches or reflections, etc. So thinking back to first semester, we learned about a series of parent functions, what their domains were, what their ranges were, and of course translating those functions left or right, up or down, stretching them or compressing them vertically or horizontally, reflecting them over the x-axis or the y-axis, etc. So thinking through that, you may wish to revisit some of those key ideas from first semester, but remembering what we did here, how this was compressed by 1/3 and how it was shifted down 2, how this was shifted left 3 spaces and it was reflected vertically and then it was moved up 7 spaces, those kinds of things. So we want to make sure that we understand all of those awesome transformations. And so here's what we're going to do. We're going to explore this reciprocal function, y is equal to 1 over x, and we're going to do that by making a table of values. All right, now I know that we have gotten pretty used to using our grapher to graph these things, but I want to see what happens at some of these fractional values. And so we're going to explore y equals 1 over x, where x is equal to -4, so this will give us -1 over 4. 1 over -2 would be -1/2. -1 gives us this. 1 over -1/2 is actually going to give us -2. All right, dividing by a fraction, multiply by its reciprocal. Remember, this is the reciprocal function, so we're obviously going to get the reciprocals of each of these numbers. The reciprocal of -4 is -1/4. The reciprocal of -1/2 is -2. Here, something weird happens, all right, because 1 divided by 0 doesn't exist, all right? This is undefined. All right, your calculator will give you like an error, all right? This location is actually not available. It's not going to work. The reciprocal of 1/8 is 8. We can fill in the rest of these, and there hopefully isn't too much of a hassle with that. If you need to compute any of those, obviously let me know. So here's what we're going to do. We want to make sure that we plot these dots, obviously, as best as we can. It's not going to be perfect because we are dealing with a very tight scale here, and that can be a little challenging for us to wrestle with this well. But as we can see, we have a graph that gets really close to y equals 0, and then over here it gets really close to x equals 0. But as you can tell, it looks like this blue graph doesn't actually touch the x-axis, nor does it touch the y-axis, all right? It's kind of a weird setup. Over here, we know that we do not have an output for x equals 0 because 1 divided by 0 doesn't exist. But for these, we can plot those other points to make sure that what happens at 1/8 or 1/4 or 1/2 or 1 or at 2 or at 4 or at 8 or at 10 or whatever else. So we can kind of see that this, again, gets really close to the x-axis without touching it. It doesn't get close. So if I had 1 over 1,000, right, it would be 1/1000th. It's still not 0, but it's really infinitely close to 0. That's what we're going to see happen. So let's talk about this function as it relates to domain and range. So I know that domain and range are old school concepts, but again, domain is the values of x. These are the values of x that we can put into the function. These are the inputs, all right? We're going to think how far to the left does it go, how far to the right does it go, are there any gaps in the domain? The range, again, is how far down does it go, how far up does it go? Are there any gaps in the outputs? Are there any gaps in the range? And so as we can see here, this gets on the y, right? It goes all the way down to -infinity and it gets up to 0, but it doesn't actually touch 0. And then it picks back up at 0 and it goes all the way up to positive infinity. So that's going to go positive infinity, -infinity, but at 0 there is no output for 0. With the domain, how far to the left does it go? Well, it goes all the way back to -infinity, all right? And it gets all the way up to 0, and it gets really close, but it doesn't actually touch 0. And then we pick up at 0 and we go on to positive infinity. So here are your domain and your range. And making sure that we can assess the domain and range and think about the domain and range today is going to be really helpful as we do our transformations. Another concept is this idea of an asymptote. An asymptote is a line that the graph approaches but doesn't actually ever touch. It's kind of a strange concept, a strange idea, but it helps us kind of make predictions for what's going to happen further on down the line. So what we should notice here is that there is a horizontal asymptote at y equals 0. Remember, a horizontal line is a y equals line. So y equals 0 is a horizontal asymptote. This thing gets really close to y equals 0, but doesn't touch. This gets really close to y equals 0, but it doesn't touch. And there's also a vertical asymptote at x equals 0. Boom, shakalaka. So x is equal to 0 is our vertical asymptote. So we can abbreviate those with HA and VA if you'd like to. I would prefer that you just write horizontal asymptote, vertical asymptote, but if you want to abbreviate those, you are welcome to. And so these functions, this reciprocal function and the derivations that we're going to have, the different versions of it, if we have a multiplier on top or a multiplier on the bottom, or if we're adding or subtracting something, we're going to have horizontal and vertical asymptotes, all right? And so let's explore this one a little bit. Let's see what happens with with y is equal to 6 over x. And let's see how that changes our picture, if at all. All right, and so we're gonna, again, I'm just gonna make a table of values here. Y equals 6 over x. Y equals 6 over negative 8 is gonna give me negative 3/4. 6 over negative 6 is gonna be negative 1. 6 over negative 3 is gonna be negative 2. 6 over negative 1 is negative 6. 6 over negative 1/2 is negative 12. All right, and then 6 over 0 doesn't exist. All right, it's undefined. We can't divide by 0. 6 divided by 1/2 is 12. 6 divided by 1 is 6. 6 divided by 3 is 2. 6 divided by 6 is 1. And 6 divided by 8 is 0.75. All right, so let's plot these dots and let's see how this shakes out, okay? We have at negative 8, we've got negative 3/4. At negative 6, we got negative 1. At negative 3, we've got negative 2. At negative 1, we've got negative 6. And at negative 1/2, we have negative 12, which is going to be way down here. All right, so this picture looks pretty similar to the one that we had before. And then what am I doing? Did I miss one? Negative 1. Negative 1 should be negative 6. I just had that, I put it in the wrong spot. We should have a 3 here and a negative 6 there. Sorry, I just put the dot in the wrong spot. Here we go. Boop, 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 boop. All right, so again, we have the same situation. It's just that it's stretched out a little bit more. We still don't quite touch y equals 0. We still don't quite touch x equals 0. But our picture is just stretched a little bit differently than before. And so this is obviously a little bit strange, but we should notice, let's see, where am I at? 6, 1, and then 8, 3/4. Okay, 3/4 is up there a little bit. So, all right, so again, we still have a domain that our x values go from negative infinity all the way to 0, and again from 0 up to positive infinity. It gets really close, but then doesn't touch, hops over, and then goes on. The range is the same deal. It's all the way down to negative infinity, gets really close to 0, doesn't touch, hops over, and then continues on. So our range is going to be the same, negative infinity to 0, again with 0 up to positive infinity. Our asymptotes, I still have an asymptote at y equals 0, and I still have a vertical asymptote. Notice how I'm doing those with a dashed boundary or a dashed line. Is going to be at x equals 0. So identifying those asymptotes is going to be a critical portion, but hopefully you're noticing that this multiplier of 6 times 1 over x is going to stretch out all of these outputs so that they are becoming more negative if they're negative and more positive if they're positive. Let's see what happens here. I would like for you to try this. Pause the video as needed, but I want for you to try this one. What would happen if you graphed y equals negative 3 over x? You can do that in the same coordinate grid if you would like to in your notes. Or you can do a fresh one, that's totally fine. And then compare what happens, all right? Find the domain, the range, the asymptotes, and then of course have that conversation. All right, so, and pause the video if you need to. Otherwise, here we go. So now we're gonna continue with translations, all right? We've talked about a little bit of the horizontal stretching, or I'm sorry, the vertical stretching on the previous couple slides. But here we wanna talk about those translations. And so this should look familiar where we have an h that's being subtracted or added to our x value and a k that's being added or subtracted from the function. And so we always want to think about these as moved over to the right h spaces, moved left h spaces, moved down k spaces, and moved up k spaces. So make sure that you write those down, but then also include these translation notes that tell us which direction we go. This is pretty intuitive on the y's, all right? We're going down k values, we're going up k values, we're subtracting, we're adding, that kind of makes sense. Over here, this feels backwards, all right? I recognize that adding h, you would think it would go forward, but that is not the case here. So if that messed with you last semester, hopefully it's not messing with you, excuse that though, anymore. Hopefully it's not messing with you anymore. But we're going to use that to think through how to write our translated functions. And so this, if I'm going to translate that 3 units back and 2 units up, then I'm going to take this parent function and I'm going to write it as x plus 3, and then I'm going to plus 2. I'm going backwards 3, so it's going to feel a little bit backwards. Over here, this function is going to be moved 1 unit to the right, and so I'm going to take x minus 1. And then 3 units down, I'm going to minus 3. I would like for you to try this one. You do letter C. Pause the video if needed. You can probably do it pretty quickly. Describing the translations, here we have the function already given to us, and our job is to say that we are taking our parent function and we are moving it to the right 24 spaces, and we are moving it down 7. Here we are moving this left or right 0, but we are moving it just up 3 spaces. All right? And then letter C, I would like for you to try that one. Can you try that one? Pause the video if needed, and I'll go on to example 4. And example 4, we get to actually graph these. I'm going to do one, and then I'm going to ask you to try one. All right? And when I say you try, I just mean you try. All right? It doesn't have to be perfect, but we're going to give this a shot. So again, we want to pick some values here. We want to understand that we are taking our function and we are moving the original y equals 1 over x, and we are moving it to the right 1, and we are moving it up 3. And so we want to explore that as best as we can to make sure that we can see what this is going to look like in our graphers, etc. But we're going to explore some of these things. So since we're moving everything to the right one, things are going to get a little bit strange. Our outputs are also going to be moving up 3. So I'm still going to have -1, 0, +1. I do want to have some 1/2 and stuff like that, but we want to maybe kind of think about this a little bit. If I know that this whole thing is going to shift over 1, all right, then that means that my picture would look something like this. All right, if it's just moving, if it's just moving to the right 1. It's just going to shift everything over. But it's also moving up 3. And so I know that that picture is going to take, instead of 0, 0, it's going to be at 1, 3 is where it's not going to touch. And so our picture is going to look like that over here, and then like that over there. So what I want to do is I want to pick x values that make sense to explore. So I'm just going to pick probably some easy numbers here just to kind of deal with it as we come to it. So I'm just going to go from -3, -2, -1, 0, 1, 2, and 3. All right, it might seem a little bit silly. I know I'm going to have to go a little bit farther over there, so whatever, we can handle that. And then let's see what our outputs are. Well, there is a setup in your grapher that can allow you to take your function, and watch how I type this. All right, I've got 1 divided by, let's see if it shows up. Here we go. 1 divided by, I need parentheses around that denominator. X minus 1, and then plus 3. All right? Now in my table, if I set my table to do asking, then I can ask it to populate the table for me. All right? So second table set, which is right here where my thumb is over a window, and then go to the table and it'll be blank. But you can say what happens when it's -3, what happens when it's -2, what happens when it's -1, what happens when it's 0, what happens when it's +1. Oh, there's my error. What happens when it's 2, what happens when it's 3. All right, so we can see these outputs and we can plot those dots. I know the rough sketch, that's the red one, of what that's supposed to look like. But let's go ahead and let's deal with these. So this is positive, because because it's moved up 3 spaces. I'm like, what's happening? That's 2 3/4. This is 2 2/3. This is 2 1/2. This is 2. This is not available. That's undefined. At 2, we have an output of 4. Here we have 3.5. I can see at 4, we have 3 1/3. At 5, I have 3 1/4. All right, so I know what the picture was going to look like, but now I can actually plot some dots. I can talk about domain, I can talk about range, etc. So at -3, we have an output of 2 3/4. At -2, 2 2/3. At -1, 2 1/2. I guess I'm off just a little bit on these. At 0, I've got 2. At 2, I've got an output of 4. At 3, I've got 3 1/2. At 4, I've got 3 1/3. At 5, I've got 3 1/4. It's getting closer and closer. And so what we can see is that this thing is going to come down like that. This thing is going to come up like so. And we can notice that there's this little gap here. There's this little gap here at the horizontal line, y = 0, and the vertical line, x = 1. We can see it in the picture. Now we might want to pick some values that are in between 1 and 0. We might want to pick like, what about like 1/3 or 1/2 or something along those lines, right? So 1/3, 1/2, those would be good. What about 1 1/3? What about 1 1/2? What would those look like? What would those outputs be? Our domain doesn't really change here, right? Our domain is also shifted to the right, so we're going to go from -infinity to 1, and from 1 to infinity. Our range is shifted up. It's not really much different, but it's going to go from -infinity to 3, and then, union with 3 up to +infinity. Our horizontal asymptote is not y = 0. I wrote y = 0 and I was wrong. That's y = 3. Is y = 3. And our vertical asymptote here is x = +1. All right? So what I want for you to consider, I just want you to consider this, is how can you predict how the asymptotes shift, how the domain and range shifts? Do you have to make a table of values like this? Can you do it in the grapher? That kind of question is reasonable. I want for you to try this. I want for you to predict what's going to happen. I want for you to make a table of values. I want for you to graph this. I want for you to identify the domain and range. And I want for you to tell the horizontal and vertical asymptotes for y is equal to -6 times x + 3 minus 1. All right? Once you've given that a shot, you should be pretty good to go. And we should have a good understanding of this reciprocal function and its translations.